Okay, I just uploaded version 2 tutorial, chapter 5 there. Okay, recap where do we stop last lecture? So for economic order quantity models, we are now at inventory management, chapter 5, inventory management, uh, and we are at economy order quantity models. We have two models, basic EOQ models and production quantity models. We have cleared basic EOQ model. Today we look at another model, which is production quantity model. Okay, we have clear basic EOQ. Today we do production quantity model. Okay, so let me check. Yeah, okay. So this is version 1 question up to here. So today you need version 2 tutorial handouts. Yeah? Okay, so when you download the tutorial, version 2, continue, I think is question 37 or something. So you need to fill in the definition for production quantity model. So what is a production quantity model? Is we use another method where the orders increase gradually. Okay, the order increase gradually means we order slowly and slowly. Compared to the basic one, we order and then we assume the order arrive all at once. That's why you see the graph in the basic, it jump at a certain point. Yeah. So today we look at another one, another model called production quantity model. We will keep on adding the orders in the inventory. So another name for production quantity model is called gradual usage. Gradual usage or non-instantaneous receipt order, receipt model. You have another two name. You might find these two name in other textbook or different material that you refer to. So production quantity model, they have another name. So some textbook they use gradual usage, or some company in their management document they use gradual usage model, or non-instantaneous receipt model. Okay, so we have assumption here. Order received all at once is relaxed. It means that with this one, there's a word relax here. It means that we have some flexibility when we receive the order, not as rigid as the basic quantity model that you learned previously. Yeah. So when you come to production quantity, there's some flexibility that you can play when you're receiving the orders. Okay, so this one just explain what is the definition of production quantity model. The order quantity you receive gradually over time, and then the inventory level is depleted at the same time it is replenished. So you keep on updating your inventory. Right. And this one, the application of this one is that when your inventory user also the producer, meaning you are the manufacturer yourself rather than you are those you buy from something and then you do assembly at your shop. So this production quantity model is suitable for those you have a different role in your company, meaning you are the one who produce it and also you're the one who use it at the same time. Okay, so just take a note on your handouts there. So production quantity model is dual for dual role, which is you are the inventory user and also you are the producer. So meaning it's a bigger factory that you do bigger assembly compared to the basic one. Or another is retailer, also producer. For example, if you're in the For example, drone manufacturer, for example, DJI. So if you go to the outlet, sometimes they are also the factory who produce the drone, and they will have a retail shop. So they send their products directly to the retail shop. So then they use the production quantity models in their inventory. Okay, let's look at the graph. So you have this graph in your tutorial handouts version 2. You will see the graph. Y-axis is your inventory level. Okay, this one is inventory level. All right. And this one is your sequence, right? Your time period. So inventory versus time. So as you can see here, the inventory, it will start from 0. Then it will go up. And then at a certain time, you will reduce. Then after reduce to 0, you will go up again. And then go down, go up again, and go down. So you will see there's a gradient line here compared to the basic order. If you compare basic order and this chart, the line is different. The basic one, you see there's a straight line jump up on compared to this gradually increase or gradually reduce. Okay, this is differences between the basic and the production quantity model. All right, then there are a few points we're going to explain slowly. So later we'll derive equation for this one and this one. Okay, so what are the important lines for production quantity model graph? There are 2 lines. First is on the top, this dash line is called maximum inventory level, meaning the maximum capacity that you can store inside your factory. Maximum inventory. You reach one point and then you will go down. Okay. So then there's another line. It's called average inventory level. This is important for your calculation later. This line, average inventory level, it will help you to do some calculation or analysis, especially for production quantity model later on. Okay, the formula is this one. So average means you divide by half. Once you calculate the maximum inventory level, and you need to use average in your calculation. So how do you calculate average? Once you calculate the maximum, you divide by half, you get this line. Okay. So there are meaning on the graph also that you can read. So what does mean this increasing line? This increasing line, as you can see, as the time goes, as you have more time increasing, what happened to the inventory level is increased. Is increased, meaning production and demand, they go at the same time. Means you produce and then you give also. Means you produce more than demand, then the line will go up. Means your inventory will add up, right? You produce more than the demand, means you have more things go inside your storeroom. Means the lines will go up. Your inventory numbers will increase. Level will increase up to a maximum. Once maximum, you stop production. Once you reach maximum, no more space for you to store things. What you do, you stop production. You switch off the machine and you distribute the goods. So the goods inside inventory will slowly go down. Okay. One is no more stock. Then you start factory again. Start factory, start to do until you no more space, and then you stop. Stop factory, stop your production floor, and then you distribute your goods until 0. No more goods, produce again. So this is a production quantity model. That's why the word production is there. Meaning, if you no more goods, you produce. Produce until you stock up your storeroom maximum. Then you stop. Then you distribute your goods until 0 again. Then you produce. Okay. So there are some few points here. For example, begin order and receipt at the same time. begin order. So it means you start ordering when there's no more stock, right? No more stock. What you do, you order from the factory, order from the production plant. Then production plant will produce. Go up to maximum. So you no more producing the order, right? So maximum, no more space for you to store already. So you stop the order. You stop the order, production will stop. So here, this point also mean you stop the order and also stop receiving any goods. Okay, stop order and also stop receiving. Then the only way go down is you distribute your goods to the customer. Okay, and then this one you just refer the formula that you use later. Okay. Okay, so this is just a notes lah, side notes. Inventory is gradually replenished as the order is received. Means you can see this line go up. So in our calculation for production model, what is important is using the average line. Okay, we use in order to determine the average, this one, we will use a few parameters. First, P and D, as you can see from the graph there. Maybe your graph is a bit small, but you can see some formula there. You're using Q, D divided by P. What is D? D is inventory demand. Inventory demand. So what is your demand? All right. So P is production. Your production rate. So if you see the ratio, right, is demand divided by production. It's a ratio 1 minus D divided by production to calculate the inventory level. Okay, if you can find the maximum inventory. How you reach maximum inventory, meaning your D divided by P is 1. Not 1. Your production 0. You stop production. Your demand always there one, but production you can control. So that's why this one you get Q multiplied by 1, this one 0. You get maximum. And average, you just divide the numbers by 2. Okay, so 2 new terms for today. On the production quantity model graph, you are looking at P and D. What is P? Quantity in your production, meaning how many you produce. Rate, production rate. And D is your inventory demand. How many you give up, you sell or you distribute your goods, right? Your demand. Okay. Okay. Next, we go to the formula. All right. So assume there's no shortage possible. So for production quantity, you don't have a shortage, meaning you do not go to the negative side, meaning your customers will not have the scenario where they cannot get goods. Right. So we have this assumption for production quantity model. We are assuming there's no shortage will happen. So if D equal to P, your demand equal to your production, there's no order size. All right. So D equal to P means what the customer demand or purchase order from the customer will equal to how many that you produce. For example, D, let's say customer order every day is 10 burgers one day, and you produce 10 burger per day. So if they are equal, then there's no order size. Right? There's no order size. If D equal to P, there's no order size because you're selling as fast as your production. So for this model to work, our production will always bigger than our demand. Production will be either equal or more than our demand. That's why you see, if our production is higher than our demand, then only we'll see increase of line over here. increase our line over here until we reach maximum. We stop production at maximum and then continue to replenish, or we sell our products to customer. You clear your inventory, the numbers will go down until 0 again. You start production, the numbers will go up again. The whole process, the demand is there. What you control is your production activity. The demand always there, meaning your customer demand will always there, but what you control is your production, how many you produce. All right. So when your inventory is 0, means no more stock, then you start production. Until no more space in your storeroom, you stop production. Then you wait until no more stock, then you start production again. Okay. Okay. First equation for today. To calculate the time required to finish receiving an order, meaning here you begin order, right? So how much time you need to finish your order. So you take your order quantity divided by the order you receive, or how many you produce. Okay. So this one is to calculate how long it takes to produce, to meet the customer demand. Okay, you take the order quantity divided by how many you produce. Q divided by P. Q divided by P. Q is a quantity, P is how many you produce. So it will give you the time required to finish receiving an order. So for example, your order size is 100 unit. You produce rate, P is 20 units per day. So what you do, the time of receiving an order, you need 5 days, because your order size, your customer or your purchaser purchase 100 unit, but in your factory you can only produce 20 unit per day. So the time you need, the order will receive over 5 days. So it just means that you need 5 days to meet the order. Okay. This is how you calculate the time. The order size is 100. Production rate is production rate. P is 20 unit per day. So basic mathematics, your order is 100. You can only produce 20 unit per day. How many days are going to take? 5 days. 5 days to receive the order. Yeah, basic mathematics here. Next, you're going to calculate the amount of inventory that will depleted or use up. Another equation, also simple calculation to calculate the amount of inventory that will deplete, use up. Meaning this equation, first equation is from here to here. How long it takes to charge up your inventory. Another one is how long is going to use from maximum to 0. This one. So what we do, we take the order divided by quantity. This is how many days you take to receive the total order, times the demand rate, which is how fast you consume the order. So you take P divided by P times D. Okay, Q divided by P times D. D is your demand rate, which is how fast you distribute your goods. So if it takes 5 days to receive the order, let's say just now you calculate for this one, it takes 5 days to receive the 100 units order. So inventory is depleted at the rate of 2 units per day. So let's say your every day you use 2 units. So 10 units will use up. 10 units will use up. So this is to calculate the amount of inventory that will use up after a certain demand is given. So this is just a simple calculation. Want to calculate how much time you need to receive the total order. You use Q divided by P. And to find the total amount that will use up after a certain period of time, depending on demand rate, what you take the first equation, multiply by the demand rate. For example, first equation, you calculate 5 days just now. 5 days multiplied by 2 days, 2 units per day. This is how you spend your inventory. You're going to spend 5 days. You're going to spend 10 units over 5 days. Okay, so these are just a simple logic here. Another one, maximum inventory level. What is this one? This line equal maximum inventory level equal order size minus amount you spend during the receipt period. How you reach this maximum? You take your order size minus the amount that is spent during the receive period. So you take Q is what you order, all right? What you order minus amount depleted during your waiting period, right? You order already, but you still need, but every day you still need to spend, you need to distribute goods to your customer. So you use the Q divided by P multiplied by D just now, this one. You will get your maximum inventory level, meaning you'll find the dot over here, over on the line here. Okay, so if you do the calculation, and you factor the equation here, meaning you have Q minus Q divided by PD. You factor the Q outside, right? You do factorization. This one, you factor the Q outside. This Q and Q is the same. You factor outside 1 minus D divided by P. You get this equation. Okay, this equation, maximum inventory line, you get from the concept of order size minus amount depleted during your waiting period, during your receipt period. So order size minus amount depleted during your receipt period, Q minus Q divided by P multiplied by D. You rearrange or you factor the Q outside. Q bracket 1 minus D divided by P. This one is this one. These slides explain why this equation exists over here. Okay. Next, once you have the maximum inventory level equation, we did this one. To find the average, normally simple data, you take average divided by 2. Right? You take half of the maximum inventory level. Okay, half of that. This is just a follow-up from the previous one. And you do factorization. If you already factor, then you just half like this, like what you see on the graph here. Okay. So two important concepts here. What is the definition of maximum inventory level? And then what is the average inventory level? Okay. Once you understand the definition, you can solve production quantity model very easily. Okay, the next one, once you find your inventory numbers, you're going to find your total carrying cost. copy this equation because later when you do tutorial question, I'm going to ask you to substitute value and you give me the answer. Okay, maximum inventory level given by Q minus Q divided P times D. P is the production rate, D is the demand rate. Average is half of your maximum inventory level. So to find the total cost of carrying, total carrying cost by using average inventory level, the purpose of calculating this average inventory level is to calculate the total carrying cost. So we have this equation, CC, which is your carrying cost, multiplied by average inventory level, which is given by this equation or this equation. Okay, so you substitute your CC. All right, your CC is a carrying cost. All right, CC multiplied by this equation. So that's why you have CCQ divided by 2 bracket 1 minus D divided by P. You have equation 1, equation 2, equation 3. Okay, give you another 20 seconds to copy the equation. Total carrying cost equal to CC multiplied by average inventory level. Maximum inventory level you can see from the graph on your handouts. Average also have. So what is the purpose of having this line? Average one is to calculate the total carrying cost by multiplying the total carrying cost multiplied by the inventory. Okay.
Excuse me, sir.
Yeah, go ahead.
So the CC is given in the table.
CC is the cost. For example, a cost per unit. Because this is you calculate per unit how many you have in your inventory. So you're given a CC cost in the carrying cost per unit, meaning for example you put a machine in your inventory there's a parking free. Like a parking free, you store like one machine there, it charge you $2 per day. So then you multiply by how many you have in the inventory. It will become your carrying cost. It's like your total parking cost. Okay. This one you'll see later in the example, in the tutorial. Right? It's a constant value. So given in the question, you just take this one, multiply by the average inventory level. Okay. The fourth equation for today, annual inventory cost, total annual inventory cost, TC. You have TC also in basic. So for production quantity model, it changed a little bit. Okay, total quantity inventory, you have one component, which is your ordering cost times your carrying cost. You have two components also. Your total cost will always have two costs. One is C sub O is ordering cost, and your CC, your carrying cost. All right, a little bit different from the basic one is the carrying cost component. Because your carrying cost component is different from basic, your carrying cost is why it's different, because you are producing as you distribute. You're producing the goods as you distribute your goods. You depends on your production activity. Right, so when you need to use this total carrying cost, when you calculate total annual inventory cost. Your total annual inventory cost consists of two costs, order cost and carrying cost. Okay, just a side remark. This component, CO, usually is a setup cost for production. right? It's a setup cost for production. Every time you produce something, you need to set up the equipment and so on. There's a cost there. You need to move a machine from one place, put it there to produce the order. Okay. Next, you want to find the optimum value of your order, right? So this is an equation, right? So you want to find the maximum quantity order that you've seen previously in basic. You see the curve, right? So you rearrange this equation, right, to find your Q op. You get the square root of 2CD divided by CC 1 minus this one. Meaning, how do you find the optimum value like what you learned in your basic model? Your order cost will equal to carrying cost. This one equal to this one, you get your optimum value. You have the curve, right? You have a graph when you calculate the optimum. Okay, flip back if you forget. Flip back to the basic quantity model. Now you just modify your carrying cost component and rearrange, you get Q op equal to square root something. This equation is for production quantity model. Okay, move on. Let's see example 3. Okay, maybe you want to copy this one. We go through one tutorial question, then we go for a short break. Okay, let's look at example 3. So example 3, you're given a loss of information here. So again, a paint company, and it tell you that they produce their own facilities. So if the statement inside there, you got tell, or they are also the producer, or they have their own production for their products. So normally production quantity model will be used for analysis. So it produce a certain paint, and then order given, CO is given, set up production, CO given. Recall that CC is 75 cents per gallon. D demand is 10,000 gallon per year. So the okay, you are given CO, CC, and D. So all these try to relate to the equation that we learned so far. We have 4 equations just now. The manufacturing facilities operate the same day the store is open. So you'll use 311 days, like what we apply for example 2. 311 days, 365 minus public holiday and some big festive season, right? And produce 150 gallon paint per day. So you have your numbers for P, right? Produce how many? Determine the optimum order size. You need to find the Q op. Total inventory cost. We have one equation to calculate total inventory cost. The length of time to receive an order, the number of order per year, and maximum inventory level. Basically, you use up all the 4 equations that we learned just now. Okay, copy the, or put the known constants one place. CO is given, your ordering cost. CC is given 0.75 per gallon. Your demand is given, D is your demand, D 10,000 gallon per year. So you calculate what the capital D is annual per year. Small d that you use to calculate is per day, because all these, some of it are given in per day. Huh? So that's why especially this one. You see this one, produce 150 gallon paint per day. This is your P, small p, or you can say as a P per day. So you need to balance because you take your D divided by P. So the unit must be balanced. So that's why how you find the small d, you take the capital D, which is 1,000 gallon per year, divided by how many days that your factory operate. In this case, the operational days is 311 day. You take 10,000 divided by 311, so you manage to find what is the demand per day. So 32.2 gallon per day. So you get four parameter: CO given, CC given, capital D given. So don't do mistakes. Don't use the capital D for the D. There's a difference between these two. Capital D is per year, but in the calculation to find the maximum inventory numbers and average inventory number, or in the four equation that you use, you are using small d. You're using per day. Why per day here? Because your production unit P is given in per day, 150 gallon paint per day. That's why you need to find the small d. Okay, you need to match up the unit that you use in the equation. P again is 150 gallon per day. So actually you have a ratio over here. Okay, so we calculate the optimum order size, which is your Q op, given by this equation. Q op equal to square root something divided by something. CO given, D given, CC given, 1 minus D calculated, P given. So basically substitution, press calculator, square root, you get your Q op. Okay, let's ask help from one of you. Muti, can you calculate for the class what is the number of Q op?
Just a moment, Doctor, calculating.
The rest you can also calculate and cross-check. Muti, answer.
So,
Yeah, go ahead.
so the D beside the CO, we use the 10,000, is it?
Capital D, right?
Yes.
What is capital D? Okay, the rest you can cross-check Muti answer. Okay, you can also calculate. So this is a time you practice lah. This is a time you practice the formula. If no, you have no time or you were busy with other module already. Okay, Muti, you can give your answer once you're ready.
Doctor, 2,256.85.
260.85. All right. So 2256.8 something, right? Correct.
Yes, Doctor, 85.
Okay. All right. Okay. So in this example, I just take one decimal place, but maximum is 3 decimal place. Minimum 1 decimal place.
Okay, Doctor.
Yeah. Okay. 2 decimal place is because your cost is in 2 decimal place here. All right, just to match up lah. Okay. But in exam, I will have a plus minus for your answer. So you have your Q op. However, you know that when you produce something, there will be no decimal place one. You don't produce 0.8 gallon one, right? Either you 1 gallon or 2 gallon, full number. So just for your info. So this one, in realistic case, when you work outside there, this number you should round up. But in this case, we'll continue to use the 0.8 gallon for our calculation. Okay. In the real production, in the real application later, if you go to production plant, you need to round up this number, become 2257 gallon is your optimum value. Because if you're producing 32 gallon more than, if you're producing 150 gallon per day, it doesn't care either is point something, all right? If it's too rigid, your workers or your subordinate or the worker that work under you, they will be very headache or have to be very chun one. Their work will be very difficult. So to make them more easier, and also for you to monitor, it's better you use round number in the production. But in our case, because we are doing analytical analysis, we'll use point decimal place here. Okay, for your test, if this one come out, in your test, use decimal place. For your test or final exam, you don't need to round up. Okay, you don't need to round up. What happens if you accidentally round up? I will still give you correct. Don't worry. Don't worry. But for your test and exam, use decimal place. Okay. So you have developed one new value here, which is your Q op 225 something gallon. Right? Determine maximum, not maximum, total annual inventory cost minimum. Why minimum word here? Because you're using Q op. So you modify the equation a little bit. The total cost, ordering cost component plus your carrying cost component. But here, why total minimum and not total maximum? Because if you want to find the minimum annual inventory cost, you are using Q op. The Q inside the equation, you use Q optimum. Okay, you substitute Q, D, all this number there. You have D and P. Okay, let me get someone to help us to calculate. The rest you can calculate. Guru Darshan help us to calculate TC. Guru Darshan, you're there, right?
Yes, sir. Give me a minute, sir.
Yeah. Help us. The rest you can again use this opportunity to practice this formula. CCO is given, D is given, Q op is on the screen here. CC also given, Q op recycle, 2, 1 minus D divided by P. Why there's a divided by 2 there? Because we are using average inventory level for our calculation.
Hello, sir.
Yeah, go ahead.
Can you hear me?
Yeah.
1329.29.
1329, yeah, okay, point something lah. Okay.
Yes.
So total cost is 1329 point something. All right. So you have found your total cost already. Okay, very good. Next, we find the length of time to receive order. This is the calculation to get how long it takes to receive the total order. So production run, or another word for, your production run is Q op divided by P. This is the quantity that you produce at optimum level, 2256.8. The production per day is 152 gallon per day. So to match up this quantity, you calculate how many days you need to wait until you meet the Q op. Okay, this is your production run. So if you do calculation, You either take this number divided by this number. You need to wait 15.05 days to wait for one order cycle per order. So if you take this one divided by this one, you need to, your production run, you need to run for 15 plus days per order. This one 0.05 you converted to minutes or hour, right? It will help you to calculate the production floor, the worker that you need to station in the production floor. Right, this one assume that if you run 24 hours, right, this is the days that you need to run, operation days. But there's a lack of information here where it tell you like how many hours per day, but this is given by the production capability here. You calculate based on the setting that you have. You need 15 plus days to meet 2,256 gallon or 2,257 gallon QOP quantity. Okay, so I put the day over there. So the next one is number of production run per order. Just now we find the production run time or length of time to receive an order. We calculate Q divided by P. We get this number in the unit of day per order. Next, we calculate numbers of production runs per order. You take the demand, capital D per year, so means you calculate in 1 year how many orders you need to, how many production run you need to stand by. Mean your purchaser need to place how many times of order. Okay, just now every 15.5 days you need to place one order. Okay, this one production run means to meet this Q, you need to place, your planner need to issue order to production floor manager, ask your worker to produce. You need to work, means you issue order to the production floor. You need to continue to work for 15.05 days so that you meet 2,000 something gallon in the inventory. Okay, so then you calculate in 1 year how many issues of order you need to issue to the production floor. Okay, number of production run or numbers of order you need to give to the production floor in 1 year. So you take gallon per year, D divided by QOP. Then you get the numbers of order you need to issue to the production floor. Mean how many cycle you need to give order to the production. Hey, come back to work. So the numbers of orders per year, mean your production run, you need to issue 4.43 times or run per year. Meaning in 1 year, your production floor will receive about 4.43 times order from you. It's about 4.5 times. So every 4 runs, over 4.3 runs, right, for 1 year order, for 1 year demand. Okay, is how you calculate. Next, maximum inventory level. This calculation already covered just now. All right, this formula we did cover. Only now we use the QOP to calculate. Q bracket 1 minus D divided by P. This is a maximum inventory level. So if you look back at the graph, this will be the upper dashed line in the graph where you calculate for the maximum inventory level. So the formula, the Q here, we are using the QOP. So you need to substitute this value, QOP, 1 minus D divided by P. D is this one, 32.2. P is 150 gallon. You get the ratio, 1 minus the ratio multiplied by the QOP. you get maximum inventory level. So I give you the answer also. Do substitution. You press calculator. You get 1772 gallon, meaning your maximum inventory level in your factory, if you are working in this paint factory, every time you go to your inventory and you check how many gallons inside the storeroom, maximum number you hit the chart will reach 1772 gallon inside there. Means if you have one drum that can store 1 gallon, every time you go and count in the store, you have 1772 maximum in the storeroom. This is the maximum number you can produce in your factory, in your storehouse, if you're given all these setting here. Okay, this is a maximum inventory level. 1772 gallon. So every time your inventory reach this value, what do? You stop production. You stop production, then it will reduce until 0. Until 0, what you do? You order again. Order to or production to start. Okay, start producing. Then produce up to this number again. Stop production. Then distribute to your customer until 0. Then start again. Produce up to this level. Stop production. Distribute again. Okay, so this is how you calculate 1772 gallon for this setting. Okay, so this one, if you are the production floor manager or you are the store manager, after you get this number from your planner, make sure your storeroom able to store this number. Your storehouse must be bigger than this number. If not, traffic jam. If not, some of your paint or extra quantity you need to put outside your parking lot. Your staff do not have a space for parking. Then another HR problem. Okay, because there's no space in the storeroom, you need to put somewhere else, and somewhere safe, because paint contain alcohol and all the chemical you cannot simply put, right? And Malaysia, if in this case is in Malaysia, we have a hot weather, then it's very costly. So paint will evaporate and so on. So you need to make sure you have the space for the product. Okay, right. With this, we stop here. After that, we look at one very interesting topic called quantity discount. This is very realistic calculation. When you go to work, you apply this one quite often. Okay, stop here for a while. Let me stop recording.